Welcome to the Linear Programming Basics 1 tutorial. This tutorial will learn how to formulate a linear program and how to solve it graphically. In the second tutorial, we will use the same problem discussed here and enter it into Excel. In the final two tutorials, we'll learn how to interpret the output from Excel, in particular the answer report and the sensitivity report. The content of this video is partly based on material from the textbook Data, Models and Decisions, The Fundamentals of Management Science by Dimitris Bertsimas and Robert M. Freund. In particular, we will solve exercise 7.3 on page 398. Before you continue watching this video, you may want to first read the exercise. However, if you don't have your textbook at hand, you will still be able to follow what we are doing by simply looking at what we are doing on the screen. The problem concerns a small manufacturer who produces two types of vases, small ones and large ones. At some point, the problem reads: a small vase realizes earnings contribution of $10 and a large vase of $12. Basically, this tells us that this is a profit maximization problem, and our objective function therefore is maximize 10 times S plus 12 times L. S is the production quantity of small vases, L the production quantity of large vases. This is the question we want to answer: how much do we want to produce of each? One of the constraints for making vases is the artist. Each vase, irrespective of size, takes 20 minutes of the artist's time, who works 40 hours each week. Therefore, we must have 20 times S plus 20 times L has to be less than 2400 or 40 hours. All our units are in minutes here, so we cannot write 40 hours on the right hand side, but we must translate 40 hours into 2400 minutes. Another constraint concerns the material. A small and a large vase require 10 ounces and 20 ounces of colored glass respectively. A total of 1600 ounces of colored glass are available. The corresponding constraint is thus 10S plus 20L less than or equal to 1600. Finally, there's a storage constraint. A small vase occupies 2 units of storage space, a large one occupies 3 units. Total available storage is 260 units. Consequently, the storage constraint is 2S plus 3L less than or equal to 260. So let's try and graph this problem. On the axis we have S and L, our quantities of production. Now, the first constraint is the artist constraint. 20S plus 20L is less than 2400. Now, that means we can at most produce 120 small vases, or at most 120 large vases. Joining these 2 points by a line yields our first constraint, the constraint for the artist. The material constraint means we can at most produce 160 small vases and at most 80 large vases. Again, combining those two extreme points gives the material constraint. Finally, the storage constraint. 2S plus 3L less than or equal to 160 means that we can at most produce 130 small vases and at most 87 or 86.66 to be exact large vases. Again, joining these two extreme points by a line yields the storage constraint. Finally, the objective function. Maximize 10S plus 12L. For example, if we wanted to generate $600 of profit, we could produce 60 small vases. Or we could produce 50 large vase and we would also make $600 of profit. Again, combining those extreme points gives us the $600 profit function. Now we know the slope. We push this out until we just hit the feasible region or just touch the feasible region. And here is our optimal solution. We produce 100 small vases and 20 large vases. To learn how to enter this problem into Excel and how to solve it with Excel, please stay tuned for the Linear Programming Basics 2 tutorial.